Alright, so in this problem, I have 5 to the power of 12 times 4 to the power of 5. So to solve this, I'm going to first rewrite 4 here as 2 to the power of 2. So now I have 5 to the power of 12 times 2 to the power of 2 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of 5, that's equal to 2 to the power of 10. So now I have 5 to the power of 12 times 2 to the power of 10. Now, 12 here I can rewrite as 2 plus 10. So now I have 5 to the power of 2 plus 10 times 2 to the power of 10. Now, if I have something in the form a to the power of m plus n, this is simply equal to a to the power of m times a to the power of n. So 5 to the power of 2 plus 10, I can simply rewrite that as 5 to the power of 2 times 5 to the power of 10. Now I have this times 2 to the power of 10. So now, if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. So in this case, I have 5 to the power of 10 times 2 to the power of 10, and that's going to equal 5 times 2 to the power of 10. So 5 times 2 is simply equal to 10. So now I have 5 to the power of 2 times 10 to the power of 10. Now, 5 to the power of 2, that's equal to 25. So now I have 25 times 10 to the power of 10. And 25, that's the same thing as 2.5 times 10. So I have 2.5 times 10 times 10 to the power of 10. And 10 times 10 to the power of 10. Well, 10, that's the same thing as 10 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, that's equal to a to the power of m plus n. So 10 to the power of 1 times 10 to the power of 10, that's going to equal 10 to the power of 11. So I have 2.5 times 10 to the power of 11. So that's my answer in scientific notation form. Alright, so in this problem, I have x is equal to x over 3. So to solve this, I'm going to first start by subtracting x over 3 on both sides. So now, these two are going to cancel out, and I'm going to be left with x minus x over 3 is equal to 0. Now, I'm going to go ahead and multiply both sides by 3. So now, for my right-hand side, 0 times 3 is simply 0. For my left-hand side, I'm going to simply distribute the 3. 3 times x, that's going to be 3x. And 3 times negative x over 3, the 3 simply cancel out, so I'll simply be just left with negative x. So now, 3x minus x, that's simply equal to 2x. So I have 2x is equal to 0. Now, if I divide both sides by 2, these two cancel out. Now I'll be left with x is equal to 0 divided by 2, which is 0. So now, to check, let me actually go ahead and take all this off. So before we check, let me actually show you guys a different method of solving this. Now, before we subtracted x over 3 on both sides, this time, instead, I'm simply just going to start by multiplying both sides by 3. So now I have 3 times x is equal to 3 times x over 3. 3 times x is simply 3x, and 3 times x over 3, the 3 simply cancel out, so I'll simply be left with x. Now, I'm going to go ahead and subtract x on both sides. X and negative x, these two cancel out, and 3x minus x is 2x, so I have 2x is 0, and if I divide both sides by 2, I get x equals 0. So that's two ways of solving this problem. So now, to check, first start with x is equal to x over 3. Now, x is equal to 0, so I have 0 is equal to 0 over 3. 0, now I have 0 is equal to 0 divided by 3 is simply 0. So 0 equals 0, meaning my solution is right. Alright, so for this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. So to solve this, what I'm first going to do is, for my left-hand side, I'm going to factor out 3 to the power of x. So now I have 3 to the power of x times, now 3 to the power of x divided by 3 to the power of x is 1, so I have 3 to the power of x times 1 plus 1 plus 1. This is equal to 1. Now, if I simplify this in the parentheses, I get 3 to the power of x times 3 is equal to 1. Now 3 here, this is the same thing as 3 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, 3 to the power of x times 3 to the power of 1, that's going to equal 3 to the power of x plus 1, which is equal to 1. And 1 is the same thing as 3 to the power of 0, because anything to the power of 0 is equal to 1. So I have 3 to the power of x is equal to 3 to the power of 0. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x plus 1 is equal to 0. So now to solve this, I'm going to subtract 1 on both sides, then these two cancel out, and I'll be left with x is equal to negative 1. So this is my answer. Now, I actually have a second method of solving this problem. So, again, I first start with 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. I factor out 3 to the power of x, so I get 3 to the power of x times 3 is equal to 1. However, now, instead of multiplying 3 to the power of x with 3, I'm actually going to divide both sides by 3. So now these two are going to cancel out, and I'll have 3 to the power of x is equal to 1 over 3. Now, if I have something in the form 1 over a to the power of n, this is simply equal to a to the power of negative n. So we can think of 3 in this case as 3 to the power of 1. So 1 over 3 to the power of 1, that's going to be the same thing as 3 to the power of negative 1. And remember, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, x is equal to negative 1. So this is my answer again, using the second method. So now to check, I had 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 1. X is equal to negative 1, so I have 3 to the power of negative 1 plus 3 to the power of negative 1 plus 3 to the power of negative 1 is equal to 1. 3 to the power of negative 1 is the same thing as 1 over 3, so I have 1 over 3 plus 1 over 3 plus 1 over 3 is equal to 1. 1 over 3 plus 1 over 3 is 2 over 3. 2 over 3 plus 1 over 3 is 3 over 3, so I have 3 over 3 equals 1. 3 over 3 is 1, so I have 1 equals 1, and this is right, so my answer is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x is equal to the square root of 32. Now, the square root of 32 is the same thing as 32 to the power of 1/2. The square root is the number to the power of 1/2. So this is still equal to 4 to the power of x. Now, when we're solving problems such as these, we always want to change these two bases so that they're the same. So what is a common factor of 4 and 32 that we can change these two bases to? Well, 2 would work. So 4, well, this is equal to 2 squared. So we have 2 squared to the power of x. And now this is equal to 32. Well, that's equal to 2 to the power of what? 2 to the power of 5. So now we have 2 to the power of 5 to the power of 1/2. Now, if we have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. So 2 to the power of c to the power of x, well, this would equal 2 to the power of 2 times x, which is simply just 2x. Now this is equal to 2 to the power of 5 to the power of 1/2. This would equal 2 to the power of 5 times 1/2, which is simply just 5 over 2. Now, as you can see, we have the same bases. Both of the bases are 2 and 2. So now this means that the exponents here are the same as well, meaning 2x is equal to 5 over 2. So now, if I multiply both sides by 1/2, so I can cancel out this 2, these two cancel out, and I get x is equal to 5 over 2 times 1/2. 5 times 1 is 5, so that's our numerator. And 2 times 2 is 4. So we get x is equal to 5 over 4. And this is our answer.